So this is a Metcal soldering iron, and you can see the tip has been kind of oxidized here, meaning it's kind of black. And so the first thing we're going to do is we're going to try to see if we can help it out. And to do that, we're going to dip it in some tip tinner here. And that's kind of just basically gooey tin. And its job is to try to re-tin and make that look a little bit prettier. It still looks pretty bad, but not too horrible. It's getting there. This is great stuff. This is called Play-Doh tip tinner. Okay, now that's better. I'll agree. And to see how much better, we're going to just put some solder on it. I'm using lead tin solder because I'm allowed to. Yeah, it's taking the solder pretty well. Now I want to show you something. You see all that smoke that went out of there? Mm-hmm. That's the flux. Now what this is, even though it's a thin wire, it actually has a very thin core of something called flux that goes down the middle of it. And that flux is a combination of things. It's a surfactant and it's a mild acid, and its job is to clean off the joints that you're going to be soldering. And that leads to the most important rule of soldering, which is that you don't want to be soldering by touching the solder to the iron and kind of dribbling the solder on, because at that point the flux is all burned off. The most important rule of soldering is you want the solder to end up touching the joint first, not the soldering iron, so that the flux gets a chance to clean off the oxides and the schmutz on the joint. All right, so this is sort of a classic example of something that you might want to be soldering. We've got some components, we've got a circuit board, and the rule is that what you want to be doing is putting the soldering iron so that it heats up everything that needs to be heated up, the circuit board and the wire as well. And then you're going to want to touch the solder not to the soldering iron, you want to touch it to the circuit board and the wire so that it melts against those two things and cleans the joint off. Now the problem with that is that a dry soldering iron, which is what this is a really poor conductor of heat. And so you have to cheat a little by putting a tiny amount of solder on that soldering iron to help with the thermal conductivity, but not so much that it ends up making the solder joint all by itself. All right, now I'm going to put the soldering iron on the joint and the wire, and I'm going to put the solder on the other side, and I'm going to feed it in. You see that the flux was activating against the joint. Now what we've got here is a shiny joint that is volcano shaped or concave, and that's exactly what you want. All right, so that's soldering components to circuit boards. The basic rule is that you want the solder to be melting against the components, and by the components I mean everything that's going to end up taking the solder has got to be nice and hot, and you want to feed the solder against that. Let's try something else here. This is a pretty common problem. We've got a connector with these little turrets in it, and we want to try to solder something to it. Now the first rule is that you want to sort of brace things so that so things aren't skittering around the table. And so I put this in a little vise here, and I'm going to solder to this connection over here. As long as there's enough of a physical connection that things aren't moving around when you're doing the soldering, then it's going to be okay. So I'm putting it in there, I'm bracing it, and it's going to be the same rule. I want the soldering iron against the wire and against the lug, and the solder is going to go against the wire and the lug as far from the soldering iron as I can, and make sure that the wire is wicking that solder in. And you can actually see that, let's see if you can tell that there's a little bit of a convexity here, but I'm not worried about it because it's beautiful, shiny, and concave everywhere else on the joint. And so that's a totally fine solder connection. You'll find sometimes when the wire wicks up the solder that you get a suspicious looking connection, but as long as you look around and it looks pretty clean and mechanically robust, then you're doing fine. There's another example here. It's a speaker, same kinds of problems. Let's just see if we can, I'm using stranded wire, which is mechanically much more robust than solid wire. When you strip it, of course, you have to pay attention that you didn't do that, which is, I stripped it a little bit too carelessly and broke one of the wires. And so one of those little rules about stripping is that when you press down on the stripper, you want to relax it a little bit after you've stripped through, so it doesn't end up scraping against the wire, and you get a much better cut there. So again, I'm placing it in there. I'm not making a robust mechanical connection, but it's not going to go anywhere. It's not going to move anywhere. It's important when the solder is cooling that when you've soldered something, especially something as large as this, that when it cools, that you give it several seconds. You have to make sure that it solidifies, or else you can get a cold solder joint. So I got the solder going against the wire and the lug, and I'm going to remove the soldering iron. I'm going to wait. There, and actually you can see it. It's a little subtle, but there's a subtle change in color there, and a perfect solder connection. Nice and concave everywhere. That's going to last the millenniums. Right, let's do, this shows up every now and then. This is a BNC connection. I want to show something that's a little bit against what I just said, but it sometimes has to happen this way. Sometimes you end up with this kind of a joint, which is called a solder pot or a solder cup, and the reason why it's called that is sometimes you end up with it, or start off with it, filled with solder, which is what we're going to do here. In this kind of situation, especially if you're the person who filled it with solder, then there's a way to do this solder connection which is exactly wrong, but also works. You tin this joint, which is called just, you take this wire and you fill it with nice fresh solder. Okay. You position the wire above the solder cup, you heat up the solder cup and the wire, and then you let the wire go in like that. Now, that was against the rules of letting the flux activate against the wire and the joint, but it actually works because it was a very clean, fresh joint. We had just filled up the cup with solder, we had just filled up the wire, and it didn't have enough time to get dirty or develop any oxides, and this is a perfectly reasonable solder connection. You'll notice after a while that the soldering iron has been doing its job, and it's starting to get full of oxides and dross, basically, schmutz, and what you do is you have to clean it off. There are sort of two techniques, and one of them I don't have anywhere. It's basically a lump of brass wire that you plunge the soldering iron into, and it sort of helps scrape it off. The one that I prefer actually for these irons is just a wet sponge, and if you want it to be sort of damp but not soaking wet. You don't want to quench the soldering iron. You just want to wipe it off, and you don't want the sponge to catch on fire. And once you do that, you're back to your basic nice clean soldering iron that you then should probably re-tin and be ready to go. So you should be doing that really as needed, but it ends up practically being every couple of joints, and it's just a quick thing. It's just a reflex. You just go there and wipe it off and get on with your soldering. Now, the thing that drives me crazy when people are working on a board like this is that they will do this. They will just cut off the traces, the component leads, which can often go flying and across the room and into people's eyes. I have definitely seen that. It is a requirement when you're cutting wires, because some of these wires can really get going, to hold them. It's very easy, and if they're so small that you can't hold them, then just cover them. That kind of thing. Just, you have to be aware of the fact that these wires can really move, and they can really hurt you and get into people's eyes if you don't do that.